For the second talk, the presenter will take us to an urgent setting. This time, it will be about disaster response. The title of the talk is Leveraging OpenStreetMap for Hyperlocal Geocoding of Twitter Data, a spatiotemporal analysis of the 2016 Haifa wildfire by Moti Zohar and colleagues. Their work demonstrate how OSM, combined with NLP, machine learning, and GI science, can geolocate tweets during a catastrophic event at different resolutions and even down to the street level.
Leveraging OpenStreetMap for hyperlocal geocoding of Twitter data, spatiotemporal analysis of the 2016 Haifa wildfire. Hello everyone, I'm Moti Zohar from the School of Environmental Sciences at the University of Haifa. I will be using the next few minutes in order to explain how OpenStreetMap data in conjunction with social media data such as Twitter may assist in managing and monitoring a cascading catastrophe. In November 2016, there were hot and dry weather conditions in Haifa. These conditions led to the outbreak of a fire that started on the 24th of that month at noontime and lasted nearly 2 days. The fire initiated at the northern eastern part of the city and spread westwards into the city due to strong winds. Along the entire duration of the catastrophe, there were many IFR, Israel Fire and Rescue Authority calls, as well as many tweets reporting of the fire that one can use in order to monitor and manage the catastrophe. The problem? The majority of the tweets were not georeferenced. That is, the metadata does not contain any geographic coordinates. The goals of the study are to georeference tweets and potential newsworthy messages, to analyze the November 2016 fire in Haifa, and to detect and monitor cascading events using those tweets. More than 2 million tweets in Hebrew, Arabic, and English languages were purchased from Twitter, organized in 144 JSON files. Each file bundles 10 minutes. The files were parsed using Python and the results were stored in SQL Server. They were filtered using topic modeling in RCNN and georeferenced using the gazetteers of OpenStreetMap and GeoNames with the Levenstein distance algorithm. Georeferencing a tweet using the Levenstein distance algorithm in conjunction with the OpenStreetMap and GeoNames gazetteers included the location of the device and also the location of the phenomena that was reported in that tweet. Once filtered, georeferenced, and manipulated, the relevant tweets reflect the temporal distribution of the cascading fire events, specifically the blue arrows representing peaks of the fire spread. Kernel distance estimation, KDE, on the left, and 3D spatiotemporal distribution on the right assisted in analyzing the tweets and monitoring the entire catastrophe. Another angle of the results. On the left, the temporal distribution of tweets classified into the associated bins of examination, and on the right, an animated spatial distribution throughout the entire prevalence of the fire. To summarize, we use the OpenStreetMap and GeoNames datasets for georeferencing complex social media data such as Twitter, we've seen that Twitter can serve as a reflector or a proxy for the fire's cascading events. We've done some spatiotemporal analysis within a small-scale region of a city such as Haifa. And we've seen that social media may serve as another layer of information for near real-time monitoring during a catastrophe. Thank you all and enjoy the rest of the conference.
We have seen another way of visualizing or visualization this time. It is focusing on a fire event that took place in 2016. And hopefully, it gave us some more ideas on different ways by which we can use spatial data to specially observe temporal patterns across space, especially in cases of emergencies.